All right, we're doing Everybody Codes Day 17. Lava. Let's see. At sign in the middle somewhere. All right. One 109. Nope. 1118. Wrong. Oh, interesting. Not Manhattan distance at all. Five 7 3. 1584. Okay, fine. So I assumed Manhattan, but actually they wanted Euclidean distance. Fair enough. Definitely 1584. Yep. See. 10. See. Okay, 1090. 4100. Mm. right now. Let's see. Interesting. How do I define a loop? By 150. Find a loop. Something like this, I think. Nice. First place. Okay, that last bit was tricky. So what's going on here? So we're given this grid in part one, and one of the squares on it is this @ sign, which is a volcano. So in part one, we want to sum up all the squares, right? All the squares have numbers on them. Sum up all the squares within a radius of 10 from the volcano. And here radius is defined as Euclidean distance. That is, dc squared plus d, what is this? dr squared plus dc squared is less than radius squared. Fine, I guess they're doing x and y. So, fine. Part one is fairly... David, I'm busy. Give me a couple minutes, okay? I'm busy, David. So we can parse out the grid, go through the grid and find the volcano, and then go through all the squares, and if they're within distance 10 of the volcano, and they're not the volcano itself, then add in that answer. So that's it for part one. Part two, we say, okay, first consider all the squares between 0 and 1 from the volcano, and add up their sum, then between 1 and 2, then between 2 and 3, and so on, except for all possible distances. Figure out which of those distances has the biggest sum, and return the sum times that distance. So fine, pretty similar. Find the volcano, parse out the grid, find the volcano, and then for all distances, if it's between r minus 1 and r, then we count it towards, r. So count it up. And if this distance has a bigger sum than the previous best distance, then record the distance and the distance, or the sum and the sum times the radius, and print out the sum times the radius of whichever one had the biggest sum. And then part three was pretty tricky. Part three says, okay, now there's a new special cell, which is an S, and you are supposed to start from the S and draw a loop around the volcano. How long does that take? So the cost of using a cell is the digit in the cell. So I guess a loop means it encircles the volcano. And we start at S and go back to S. And also, every 30 seconds, the volcano spreads and destroys more squares, and we can't use any destroyed squares. So fine, what do I do? So, get the grid, parse out the volcano and the starting square, and for the distance, we can just enumerate that. So we're saying, can we, draw a loop before the volcano reaches distance whatever? It says it takes 30 seconds to go each distance. So like if we want to complete it at distance 0, we have 30 seconds to do that. Maybe I should say -1 here. And then, so it took me a while to think about like what it means to make a loop. But I think what it means is that we have to draw a path from S to somewhere below the volcano. Actually, we have to draw two paths. One of them goes to the left, and one of them goes to the right. So I'm defining, to find the left path, I'm saying you can't go through anywhere square to the right of the volcano. I'm assuming that the optimal path does not like come down to here and then go around. And similarly, for the right path, I just say you can't go to any square to the left of the volcano. And then, so a loop is, we're going to hit somewhere below the volcano. So just try all possible squares below the volcano. As long as that square is not destroyed, we can take our two paths to that square, including the square itself. And if that completes in our time limit, then that's our answer. So how do we compute these left and right distances? So we can just use Dijkstra. So this is going to be our distances. This is the Dijkstra Q. So we start and we say S is at distance 0. And then grab the next thing from the heap. Yeah, I guess I should say heap. If it's out of bounds, that's invalid. If it got destroyed by the volcano, that's invalid. If we were going left and this square is to the right of the volcano, that's invalid. If we were going right and this square is to the left of the volcano, that's invalid. And if you've already been here, that's invalid. Mark that this is the distance of the square, and then consider going up, left, right, and down, which we have to pay to go through our current square, and we move in that direction. So that lets us compute sort of left distances and right distances, and then we can use that to compute the cost of the loop. So this was this was kind of hard for me to think of, but I think it's kind of a nice solution. This is technically, a little bit wrong in the sense that, like, in theory, the optimal path could go all the way down to the left or the right of the volcano, but in practice, because all the digits are 9 or less, it would be very wasteful to go all the way around like that. So I wasn't too worried that that was incorrect. Interesting. Yeah, I wonder if this, clearly there's some special properties of this input. Like, it's all 9s below the volcano, and it's also all 9s sort of next to the starting square. So I think both paths are going to leave by this little path here. So anyway, that was it for today. See you tomorrow.